So here's our first algorithm in determining a minimum spanning tree, and it's super easy. First, you can actually pick anywhere in the graph, because frankly, we'll go over this a little bit more, but I'll spit it out here a little bit. We're going to hit every node anyway, so we might as well pick any node, but then the smallest one to connect to another node, because it's probably going to be used anyway. So for giggles, I am starting at A. I did not have to. I could have started somewhere else. And here's the entire graph. Notice all the edges. Yes, again, there's cycles. And we're going to build, frankly, well, a tree from that. So in our first step here, starting with A, I'm given two options. We're cheap. We're going to go with the lowest cost. So we're going to go ahead and pick that 4, as you see that's highlighted. Now, when we do that, we're actually given more options, because now we have B that's connected, and it's got other options itself to connect to other ones as well. So in this stop right here, we're looking at a cost of it 2 8s and then 11. Which one do you pick? Because you know both of them are 8s, and that's better than 11. For now, we actually picked the lowest named vertice. So in this case, it'd be C over H. So you'll see that pop up on our next one there. Then C gives us a lot more options. Notice it gave us a 7, a 4, a 2. All these items that are highlighted, except for some reason number 11, these are all of our items that we want to frankly pick from. Which one's the cheapest from that? Well, it's going to be I. I only took 2 to get there, and I gives us more options. So notice all these options that we keep getting, we're picking the cheapest one. So let's see, and this one looks like I'll connect to 4. I got F now. F gives me a couple of more options. Well, what do you think's gonna be next? Out of all these options that you see over here on my left-hand side, what do you think it's gonna be next? Well, number 1, it's gonna be an edge that we haven't already connected to. That's the only thing that you have to be very, very careful about. Now, in reality, it's gonna be the 2 and would get us into G. But in reality, we gotta be careful that we're not picking an edge that already is connected to the graph, so we don't make a cycle. We'll talk about that here in a little bit. But that's your Prim's algorithm on exactly how to get through a tree. And again, each time we check to make sure it doesn't make a cycle. So this is just a continuation of the previous that I was showing you, just frankly in words. So again, we're going to start with adding really any node that we want to, and we want to continue adding the lightest edge, which really is the greedy portion of it. We're optimizing to figure out what's our lightest, so that's our greedy. I know greedy sounds like you want to take the most, but you want to take the most optional, or not optional, but optimal value that you want, in this case a minimum cost, because it's a minimum spanning tree. Then we keep going with our initialization, and then we're going to have a repeat loop, as I showed you before, of constantly checking which our next optimal value is going to be to add to, frankly, our list of different items. We just got to make sure that there are no cycles in this, and I'll go over how to do that here in a few moments, but this is again just a written version of the exact same thing that we just covered.